evening. Welcome to SVN3E, Grade 11 Environmental Science. My name is Wendy Espana, and we are working tonight on Lesson 15, Conserving Energy. And we're going to work in the booklet to start our work on energy conservation, which is actually a big topic in this course. And we're going to start with the booklet. So you're going to go to page 21, and it's Unit 3, Lesson 15. Okay, I've got it on the screen there, and we're going to go into here. We're going to look at our learning goals to start. So, Lesson 15, learning goals. Students will be able to identify and use common units of energy and describe several methods of energy conservation at home and at work. Okay, so a big part of the course, of course, is looking at the three spheres. We started that off. Then we looked at how they're affected by human activity in particular, but contaminants and etc., how we monitor that, measure those contaminants. We've done all that work. Then we looked at a lot of how those the human body works and how we protect ourselves from contaminants. And we looked at how if contaminants get in, what happens, and all that type of thing. So we've covered quite a bit. Our latest thing now that we're going to cover is we're going to look. Sorry. And then, of course, the last bit of work we've just done is our work on looking at how we produce electricity. What are all the forms we produce electricity? And we looked at all the different ways. And then we looked at, after that, we looked at benefits and costs to each method. So each method has its positive parts and then its negative parts. And the one that we said we no longer use is coal. Coal's no longer used as a form of electricity or a form of energy to produce electricity, but that we use a lot of hydroelectric power and we use a lot of nuclear power. And we then also use alternative methods. We had to fill in for when we stopped using coal in Ontario in particular, and came up with some other methods. Okay, so that brings us to tonight. Tonight is looking at conserving energy, reducing the amount of energy we use. And this is a huge issue in the world, I suppose, but in particular in environmental science, because if we use less energy, then we don't have to produce as much electricity, right? If we don't use as much, we don't have to produce as much. And we know that no matter what type of energy, whether it's renewable, non-renewable, the renewables obviously are better forms in that they don't produce as many emissions, as much pollution when we produce them. We don't have radioactive waste and all that kind of thing. They still have a cost, and there's even if it's something that's very, very good, like doesn't damage the environment, all the rest, it still has a cost. There's still something we have to do to produce that electricity. So we're going to start by looking at calculating energy use and costs. So there's a couple of terminology, there's a couple of new words that we're going to learn. One of them is looking at what is energy. Okay, so energy is the ability to do work. Okay, now then I guess the question is, what do we define work as? Work is when we use a force to move an object a distance. Okay, to lift something up, to push something. That's work. When we need to move an object a certain distance is work. Now, energy then is that we have the ability to do that work. So if you're going to lift something up, then we do the work. The object moves a certain distance. That's work. And the energy to do that, to lift the book, is energy. It's the ability to be able to lift the book off the desk. Okay, another word that we always use when we're talking about calculating energy use and costs is power. And it's how much work we do over an amount of time. So it's the amount of work done over an amount of time. So if we're looking at lifting something, okay, we're going to take the amount of work it takes to lift, okay, over how much time it takes to lift it. If we lift something slowly, and then we turn around and lift something quickly, we're doing the same amount of work, the same objects moving the same distance, okay? So that's work. However, if we do it very quickly, if we want to lift the object really quickly up, then that will take more power than lifting the object slowly. Okay, so power is over time. We have units of energy, and we have units of work, and we have units of power. We're going to go through those now. So for energy, we usually use the joule. There are other forms of energy, and we will talk about them when we go to the textbook. But for now, we're just going to stick with the joule, which is what we use in Canada. It's represented by a capital J, and it's joule. You'll see on page 22 of the booklet, it's Joule. And the symbol for joule is a capital J. So it's not like a jewel like in a ring. It's a unit of energy. Okay, 1 joule of energy is how much you would need to lift a novel, just, a book, about a meter up off a desk. Okay, so you're going to take the book and you're going to lift it. And a meter, in the classrooms, the meter stick the teacher has, the long ruler the teacher has, it's called a meter stick. That's how far a meter is. So if you were to take the book and you were to lift it up about the length of a ruler, that is 1 joule of energy. Okay? That's what we're going to use for our to imagine how much energy that is. Now, if we look at a light bulb, you know that light bulbs, if you've ever had to go and buy any, I don't know if you've ever had to go and buy any, but if you go and buy light bulbs, you will know that on the light bulbs, it doesn't tell you how many joules of energy the light bulb's going to use. It tells you the watts, W-A-T-T-S, watts. All right, so now light bulbs usually have somewhere from 40 to 60 to 100 watts. And for those of you that go out and buy light bulbs, you know that you buy the amount of watts depending on how bright you want the light bulb to be. If you're using it and you don't want it to give off a lot of bright light, you'll use a 40 watt. If you're using something like in a lamp, maybe in a living room, somewhere where you do want, next to your bed, you're probably going to go with about 60 watts. If you want maybe in your kitchen, you want lots of light when you turn the light on, because maybe you're cooking or you're doing something, you would probably get a 100-watt light bulb. Okay. Now you'll see the term incandescent light bulb, and incandescent light bulb and the newer ones we're going to talk about in a little bit, but just know that watts is what we usually buy our light bulbs in. Okay, so what is a watt? It comes from a scientist named James Watt, and it's how we measure power, and it's how much energy that the light bulb is using over a time. Okay, that's what a watt is. It's power. We're measuring power. So a watt is that 1 joule of energy. Remember, the joule is lifting the book 1 meter up in the air off a desk, say. And then the watt is a joule of energy used for every second. Okay, so to use a dim light bulb, you're going to use 40 joules of energy every second. That's a lot of energy, right? However, a joule is not that much energy. So it's 40 joules every second. If you have a higher power rating on a light bulb or an appliance, it means that that device or that light bulb's using more energy every second than a device that has a lower power rating. So if you have a 40-watt light bulb, a 60-watt light bulb, and a 100-watt light bulb, the one that's using the most energy is the 100-watt light bulb. Okay, the higher the number of watts, the higher the energy usage every second. If the power rating is multiplied by the time it's used, then we can calculate the electrical energy. So if we go over to page 23, there's an equation. Energy is equal to power times time. Okay, or we could use the symbols E for energy, P for power, and T for time. So there's our little formula. E equals P times T. So if the power is in watts, which is joules per second, and time is measured in seconds, then the energy when we multiply those two is going to be measured in joules. So to have a power rating of 1 watt, you have to lift your novel up 1 meter for every second. Okay? If you lift it slower, your power rating is going to go down. It's going to be less than 1 watt. If you lift it faster, your power rating is going to increase to more than 1 watt. So if you leave a single 60-watt light bulb burning in your home for 12 hours, how much energy was used up? That's the kind of equation, or that's kind of question that you can use for this equation. So we know that the P power is 60 watts. So we're looking at page 23. And we know T is in 12 hours, but we know 60 watts is in joules per second. So we have to change so that we have similar units. So we can't just plug in T time with 12 hours, okay? Because the power is measured in watts, and watts is measured in in joules, per second. Okay, so we have to change 12 hours to seconds. And how do we do that? Okay, we know that 1 hour has 60 minutes. So 1 hour has 60 minutes, and we know that each minute has 60 seconds. So if we take 60 times 60, we go 60 times 60, that's going to give us 3,600 seconds in an hour. Every hour has 3,600 seconds. So if we take and multiply that by 12 hours, that gives us 43,200 seconds. Alrighty? So we're looking now at the fact that we have a power of 60 watts, or we could write that as 60 joules per second, and a time of 43,200 seconds. So now we have 2 units that we can put in our equation. So we write our equation E equals power times time. We put in, instead of power, we replace with our 60 watts or 60 joules per second. We multiply by 43,200 seconds, and the amount of energy is 2,592,000 joules. That's 2.6 million joules of energy. Leaving a single light bulb on burning for half a day is just used up over 2 million joules of energy. However, like we just talked about, a joule is a very small unit of energy. So what we do instead of using joules of energy, because you can imagine if think about it, you've got a light bulb burning for half a day giving that much. Can you imagine trying to calculate your bill from the electric company, right? Because we do a lot more than that, right? We run our appliances, uh, washers, dryers. We use fridge, stove, hot water heater, microwave, televisions. Everybody's got their own device plugged in. We've got all the games that we use and all that. Okay, so if you can imagine that one light bulb is going to give us that much energy being used in half a day, that we have to come up with a more convenient unit of energy to calculate when we do our hydro bills. And so we call it the kilowatt hour. Kilowatt hour, that's what the hydro company uses for its unit of electrical energy. And the formula for that is 1 kilowatt hour is equal to 1 kilowatt times 1 hour. So a kilowatt, what is that? Well, anytime we see that K in front of a unit, remember watts are W. I don't know that we've said that yet, but a watt is W is the symbol for a watt, and a kilowatt's kW, and a kilowatt hour is kWh. So every time we see a K in front of a unit, we know it's 1,000 times that unit. So a kilowatt, as we'll see on the next page here, oopsie, is 1,000 watts. So when we talk about units of electrical energy, we have 1,000 watts, a kilowatt, and we have 1 hour, so that we don't use big crazy amounts. So the question is, just a sec, just gonna have a quick look. Yeah, we didn't go through so let's do that calculation ourselves. So let's just go up here to our calculator. Just give me a second and I'll get it on the screen. Alrighty. There we go. And we'll get our calculator on the screen. Okie doke. And alrighty, there's our calculator. So we know that we had, let's just go back to our question here. We had 60 watts. So now if we take 60 watts and divide by 1,000, that gives us our kilowatts. So you'll see it's a small amount when we're talking about kilowatts, because we're going to take our 60 and now we're going to make it out of 1,000. Okay, now we're going to say times 12 hours. These are in hours now. And you'll see that 0.72 kilowatt hours, which is much easier to deal with than what did we have? 2,592,000. What was those units in? Those were in joules. So you'll see that the 0.72 kilowatt hours is a lot more reasonable to be using than the other method of finding that. Okay. And I'm going to go back to page 24 of 27. Alrighty, and we're looking at reducing energy use with simple changes. So this is the main part of the lesson, is that how do we reduce energy use in our everyday lives? And remember, by doing this, it's not just that our bill's going to be lower, which is great. We do want a lower bill. Don't get me wrong. I don't want to pay big bucks for electricity. However, it also means that we don't have to produce that much electricity either, right? If we take and we reduce, if every household reduced how much energy it was using, then that means that we don't have to have as much electricity produced by dams and by fossil fuels burning, by nuclear energy. And so we don't have as much pollution being produced, etc. So that's the big part of trying to reduce it. You probably already know some of these suggestions, and I'm going to highlight a few of them as we go through, but there'll be some newer ones lower down that we'll get to in a minute that you might not heard of. Okay, the first one listed is turn off electrical devices when they are not in use. So I know, for instance, in my home that we have a PS4, and I know I have an Apple TV. I have, I think that's it at my house right now, actually, and TVs attached to them. So what I do is I have a timer on the Apple TV, and I also have one on the television, but the Apple TV will actually shut off the television, so that's good. So putting a timer on so that if you fall asleep and you don't turn off the TV or the device or whatever, it will automatically go off. Those are really good to do. When I turn off the TV in the living room, it's attached to the PS4. Which sounds like ancient technology now, doesn't it? But anyway, when I turn that off, I make sure that I turn off the PS4 before I turn off the TV. When you leave a room, turn off the lights, right? Don't leave lights on when you're not in the room. Turn off lamps, turn all that stuff before you go to bed. Make sure all the lights are off in the house. Make sure all the devices are off in the house. Okay, so that's a biggie. Just turn off devices when you're not using them. Second one, don't leave the fridge or freezer door open for too long. We're going to get into this in another lesson, but what you're actually doing is letting the heat in. You're not so much letting the cold out as the heat's getting in, and then it has to then make it cold again. And to make your fridge or freezer cold, it uses electricity. And those are once it's warmed up, it takes more to cool it down again. So open the door, get what you need, and close it again. I've been doing that for quite a while, and I think my father must have harped on me about that, because I know that one. I live by that one. Okay, wait until the dishwasher and the washing machine is full before using. This one's, again, these are good for bringing your electric bill down, but also good for not having the electric companies create electricity they don't need. Don't run your dishwasher half full. Wait until it's full and then run it. Washing machine, don't throw in one pair of jeans and run it. Wait until it's full. Now, washing machines also can run on cold water now. There's detergent, it's cold water detergent. It works just as great as regular detergent. As a matter of fact, your clothes will last longer if you're washing them in cold water instead of hot water. So you want to make sure that you're using cold water whenever possible. If you have to wash in hot water for something, that's fine. Put your setting on hot for that one, hopefully small load. I can't imagine you're washing anything too big in hot water. And then go right back to using cold water for all the rest of the things. And your clothes will last a lot longer if you wash in cold water. And the detergents nowadays are better detergents. Don't keep your home too cool or too warm. Okay, that's because it costs money either way. So remember, I was talking about having my gazebo on my deck, and once I take my gazebo down, if it's still warm, if it's still not quite fall or winter yet, my house heats up. And sometimes I have my air conditioner still in. I do have an air conditioner I use. And sometimes once I've taken down the gazebo, I do have to turn on the air conditioner a little bit more. But I try to keep the temperature of my air conditioner so that it's not getting my house cold, but just cooling it enough that it's comfortable. Then I use fans, which use less energy. I use fans, ceiling fans I installed in the rooms. That really helps keep the rooms nice and cool and circulate air. I have fans in my hallway. You also don't want to keep your house too warm. And we're going to talk about heating your home in a little bit here. But you don't want to be wearing shorts and a tank top in the middle of winter. Put on a sweater, some nice cozy sweats, and some slippers or a onesie. I have some nice onesies that my kids bought me, and they're so comfy. And don't keep your home too hot or too cold. Keep doors and windows closed as much as possible if the temperature outside is uncomfortable. So if it is boiling hot outside, keep your windows closed and your curtains. Like, keep your house nice and dark. It'll stay way cooler. If it's a nice warm sunny day in the winter, open your curtains. Let the nice warm sunny air come in. It'll warm up your living room. But don't leave your door open. I always say to, my kids, if the heat's going and they've got the door open, are they trying to heat northwestern Ontario? So that's another one. You don't want to keep your windows or your doors open if it's hot outside or it's cold outside and you're trying to keep the inside a different temperature. This one's an interesting one. Try to invite members of the household to watch the same TV program instead of everyone using a separate TV. That's usually not a problem in most households now, but it might be a problem with people using their own devices. So iPads, phones, gaming systems, those might be something that everybody's using. I always usually had a rule that those types of devices were in the living room, and that way everybody had to take turns using them so that, nobody was on their devices all the time. I think that's very different nowadays. I think it's very different way that we live, and I think that's a lot harder. It says even better, try some activities that do not use electricity. So I love to go kayaking. I love to go walking. I love those kinds of activities. So those ones are really good for not using electricity. Getting outside, reading a book, all of those are good activities. So just limit how much time you're using devices, I guess, is the biggie. There's a thing pops up on my phone now that says screen time, right? How much time I was on my phone and whether it's up or down each week. And that's all good stuff to keep track of and to try to lower the amount of screen time. It's just healthy. It's healthy to not, have a high screen time, and you're going to reduce the amount of electricity. Alrighty, it says use hot water sparingly when taking a shower or bath. First of all, I know this from years ago. A shower uses less water than a bath. So if you can shower. It's going to use less water than a bath. But also try not to have it too hot. Long hot showers, a long hot bath use a lot of electricity. We're going to talk about water heaters here in a minute as well. Okay, some other sources of power that you might not be sure of. Phantom power. When many of your electric devices and appliances are off, they're actually still using electric power. So if something's plugged in but not being used, for instance, a computer, the fan, right? The fan in the computer will go on. Like I was saying, devices, I turn off the TV, but the device is still going. those are more obvious ones, but other ones are just that it's plugged in. I have a drill, and I like to have my batteries charged for the drill, so that's often plugged in, even though I might not use it for weeks. That's a phantom one. And gadgets that are plugged in, that I might not even be using. So all you have to do with this is unplug them or turn them off when you're, not just turn them off because they can still be drawing power that you're not even aware of. But the suggestion here is to have things plugged into a power bar and then unplug the power bar. And if you are just not even unplug it, switch it off, right? And that way nothing's going to be drawing any power. I have a light switch in my living room, which I love, and the light switch turns off all the devices in the living room when I shut it off. So I find that very useful. Okay, the light bulbs. So we talked about the incandescent bulbs. Nowadays, those are old-fashioned light bulbs. All right, and the way you know something is an incandescent bulb is that it gets hot. So even if it's only been on for a couple of minutes, it produces heat. Back in the day, parents used to take, and if you were sick, they would take a towel or something, they would put it on the lamp, on the light bulb, and then pull it off and put it around your neck with Vicks. This was a cure for when you were sick. And the light bulbs were hot. So that is, those were incandescent light bulbs. As a matter of fact, only 5% of the electricity going into an incandescent light bulb makes light. The rest of it just produces heat. So for the most part, all they did was get hot. And that's wasted energy. So if you probably never even have had incandescent light bulbs in your house anymore. Mostly now we have CFL lights, a compact fluorescent light bulb, and it is more efficient. It uses more of the energy that it gets from the electricity and produces less heat. It says at the bottom of page 24, on average, it is 3 to 5 times more efficient than an incandescent bulb. Now, these light bulbs, I'm going to show you a picture of them here because I'll show you the difference between an incandescent versus CFL. Okay, here we go. Let's have a look at what it says here. Now, this is different, 3 different types here. There we go, beautiful. Give me a second, you'll be able to see that on your screen. Okay, so we have the incandescent is the one furthest to the right, and you'll see it lasts for about 1200 hours. All right, it doesn't contain mercury, and it uses about 60 watts, and there's our 90% energy loss to heat. We said 95, but this one says 90, so it's about the same. In the middle is the CFL light. It has an average life of about 8,000 hours. This one says it contains mercury, so we'll have to check into that. It uses only 13 to 15 watts, and it uses 75% less energy than the incandescent. Those CFL lights are the ones that you see a lot today. Now, interestingly enough, not all CFL lights look like that anymore, right? And we're going to look at some examples of some different ones in a sec. But just know that they last much longer and they use way less energy. There's an LED light. They have an average life of 25,000 hours. They don't contain mercury. And they only use 6 to 8 watts, and they use 84% less energy than the incandescent. So that's a nice chart that's showing you the difference between those 3 light bulbs. And there's some more pictures of fluorescent light bulbs. That's another type of light bulb. I have fluorescent light bulbs in my kitchen, so sometimes you'll see those types, and that's a whole different area too. But know that there are nowadays lots of choices for what you can use for light bulbs. Okay, we'll go back to page 25. And you'll see now it says there are some concerns with CFLs. The light they produce is slightly different from incandescent bulbs, and the bulbs sometimes get very bright quickly, but don't get maximum brightness for a minute or so. Okay, so the light might be different. However, that's not really true with newer versions of light bulbs. The light looks similar nowadays, and the brightness is almost immediate. I have to say that for the most part, maybe I'm just used to it. Maybe that's part of it. I'm just used to it being like that. And there's also LED lights. Christmas lights, in the old days, we had Christmas lights that would get very hot. You'd have to be very careful. You'd have to be, don't turn your lights on for too long, and make sure you turn them off before you go to bed. Nowadays, with LED lights, which is another type of light that we now use quite a bit, we don't even have to worry about any of that because they're all they're cooler, so it's not even an issue. So there's different. The point being, when you go to the store to buy lights, buy a light bulb. I'm talking about light bulbs. Buy ones that are gonna be, less, using less energy, producing just as much light, but not costing you as much energy, as much money. Programmable thermostats is next on our list. Okay, so the thermostat is what you set on the wall to how hot you want your house. So a programmable thermostat helps you to reduce the amount of electricity you're going to use to heat your home. How does it do that? So a traditional thermostat, you go to the wall and you set the temperature that you want the room at that particular moment. Okay, so you get up in the morning and it's very cool because you've had the thermostat turned low, let's say during the night. So you go over and you turn on the heat in the morning, and then your house heats up nice and warm, and you have your breakfast and get ready. And then you think, okay, now I'll turn it off. Or don't turn it off. If you turn off the heat and it's really cold outside, you'll actually burst your pipes and cause all sorts of damage, and that won't help at all. But let's say you're going to turn it down to go out. You're going to go for work for the day. You don't have any pets. There's nothing at home that's, needs the house to be that warm. So you turn it down to a half decent temperature. When you come back home, you turn it back up again. Okay. The problem is remembering to do all that. You're running out the door. You're really busy, you got to get to work, maybe you're late, and you forget to turn down the heat. Well, then what happens is that you have paid all day to have a warm house for absolutely no reason. So what happens is you use a programmable thermostat. Yes, you do have to purchase it at the hardware store. You may have to get somebody to help install it if that's not your thing. It's not my thing, so I hired an electrician. Did not cost much. They actually fixed my furnace while they were installing the programmable thermostat, which was really nice. And what I do is I believe it's 4 temperatures. So I start by setting the temperature, I believe, at 7 in the morning. That's when my heat goes on at my house. And it stays on probably for about maybe an hour, maybe. I'm not even sure if it's that long. I should really go home and check before I tell you. But I'll tell you when I check tomorrow at the next lesson. Then the heat, I've got it set at 8 o'clock, let's say, to go right cool. Very cool. I'm not home. I don't need the heat on. I have it to come back on again around 5 o'clock at night, I believe. And it's on for the evening until 11. At 11 o'clock at night, the temperature goes right down while I'm sleeping, right till 7 in the morning. And that's it. I don't have to do anything. I just have to set it once, and it does that. In the summer, I can, or as maybe it's getting warmer, I can make and adjust those temperatures. Maybe the days are getting longer, whatever. In the summer, I can turn it off. I just turn it right off, and don't use any heat. So you can see how this can be a huge savings and easy. So highly suggest that that's one of the things you can do. The bottom of page 25 is tankless water heaters. So I haven't not switched to a tankless water heater in my home, but I do have one in my trailer. And at first I was a little bit nervous. They call it hot water on demand is another way, and it does have its pros and its cons. So when you have a regular water heater in your house or wherever in your trailer, it gets full of cold water, and it has a heater in it that heats the water, and it keeps it hot so that whenever you turn on the hot water tap, you have hot water ready to go. If it's sitting there for a long time and doesn't get used, it might cool down a bit, and then the electricity kicks in and heats it up again. So you can see that it could be a big waste of electricity if you're heating up the water, but it's not even getting used. Okay, and it keeps it hot all the time. It could, even if it's the best water heater, it's got the best insulation and the best method of heating it, it's still a lot of wasted time sitting there, not getting used. All right, so what you do is you get hot water on demand. Okay, and that is a device, and it can use gas, it can use, whatever method you're, propane or whatever you're using to heat. Maybe you have a fireplace and so you've got propane attached, or maybe you're using electricity to heat it. In my RV, it's propane. Propane heats my tankless water heater. When you turn on the water, it gets heated when you turn it on. There's no hot water in a tank waiting to be used. And so you turn on the tap and it produces hot water as you need it. They require, if it's an electric tankless heater, they'd require a lot of electricity because you're heating the water right then, right on demand. Okay. If you have gas or propane, it could be a little bit more expensive. Hot water tanks are usually not that expensive. Well, they're probably a couple of $1,000s, I imagine. But tankless water heaters are usually more expensive to buy. And if anything goes wrong with them, it's probably more difficult to find somebody to fix them. So you want to be very careful that you're, if you're going to make the switch, that you are doing it with the understanding that it will cost money to originally set it up, and you need to have somebody to help you in case anything goes wrong with it. I have good friends who have one, and they're like, that's what they've had. They don't see any difference. I found in my trailer when I used it this summer that sometimes it took a little bit of time for the water to heat up to the temperature I wanted. But once it did, it was fine. Like when I would have a shower, I would run my water for a little, not very long, not that long. I'm not like, we're talking like not even a minute probably, but a little while. And when you're camping, it's always such a big deal, the water, right? You're trying not to use water up if you are in a place where you're not attached to water, you're not attached to sewer, that those are, you're gonna have to go over and refill or dump your sewage away. If you're very aware of how much water you have, how much is in the sewer tank and all that stuff. So it's really important that you're careful with water. So the biggest complaint for people using them is usually the amount of water you have to run before it gets hot to the temperature you want. However, once I get it hot, then I go to use it and it's nice hot water. I shut it off, so I'll run it to wet my hair, then I shut it off. I shampoo my hair, then I run it to rinse my hair, shut it off. Then I lather up, let's say, put in conditioner, whatever. Then I run it. So it's not like a typical shower where I would stand under the water and shower. I actually turn the water on and off as I'm showering. The same with doing dishes. I'll actually probably fill the container I'm using with hot water and use that instead of, running hot water in my sink like I might. The other thing we haven't talked about, but I thought it's a good topic for conserving energy, is when you use it. So we'll probably talk about that a bit more tomorrow night, but I do want to just mention it, that when you use electricity has become very important. So let's just see for a minute here, optimum times. So these are produced by hydro. In our area, it's we use Sioux Hydro. And so let's see if we can get hydro optimal times, and we'll see if we can get some statistics on that. Okay. It's not going to give us the actual hours. Okay, let's just do optimal times to use hydro in general in Ontario, let's say. Okay, let's have a look. Okay, here we go. So what happens is, depending on when you use, sorry, I gotta put that back on. Sorry, there it is. When you use electricity, it is how much they charge you is based on when you're using it. Okay, so to optimize electricity usage and save on costs, here's the optimal times to use hydro in Ontario. Okay, off-peak hours. These are the hours are generally cheaper because less people are using electricity at that time of day. So the cost is cheaper because less people, there's less demand for the electricity. Those hours are 7 p.m. at night to 7 a.m. on weekdays, all day on weekends, and statutory holidays. Okay, so this weekend's coming up. So from Friday night at 7 p.m. until Tuesday morning at 7 a.m. is off-peak hours because it's the weekend. It's from 7 at night, right through the whole weekend on Friday night. And Monday is a statutory holiday. So that means that your off-peak hours would be from 7 p.m. to 7 a.m. So all weekend. Mid-peak hours. Utilize electricity during mid-peak hours are from 7 a.m. to 11 a.m. and 5 p.m. to 7 p.m. on weekdays. Okay, so they're cheaper than peak hours. 7 a.m. in the morning to 11 a.m. in the morning and 5 p.m. at night to 7 p.m. at night. Those are during the weekdays. Okay, so those are also less money than peak hours. Okay, peak hours. Avoid using electricity during on-peak hours which are from 11 a.m. to 5 p.m. weekdays, the middle of the day, when everybody's at work, everybody's at school. There's all sorts of electricity being used up. That's known as on peak hours. And that's when electricity is the most expensive. This is where having the thermostat on your heat really helps. Also, if you're going to run the dishwasher, wait and have it run while you're in bed. Most dishwashers nowadays come with a timer, so when you're going to bed, put your dishwasher to come on while you're sleeping and while it's on off-peak hours. All right. If you can stick to that, it's a really great way to get your hydro bills down. And again, by doing that, we're conserving electricity, and we're just helping not have to produce as much electricity as we usually do if we're using electricity we're not following any of the conservation rules, and we're using electricity during the on-peak hours. Alrighty. That is it for our conserving energy tonight. We will be back tomorrow. We're going to go into the textbook. There's some, as always, I really like the way the textbook does terminology. And we're going to go through some of the terms we just went over briefly tonight. Like we'll go through some of the joules and watts and power and that kind of stuff again tomorrow. And finish up our work on conserving energy. Thank you for joining me tonight, and we will see you tomorrow.